Welcome to talk about finding dead metrics and silent alerts in your monitoring system. My name is Roman Khavronenko. I'm engineering manager at VictoriaMetrics. And VictoriaMetrics is open source time series database and a monitoring solution. Actually, we are more than that. We are also logs database and traces database. All this is open source, horizontally scalable under Apache 2 license. So go and check it out on the GitHub. It might be very useful for your projects. Okay, so the key point of my slides today, my presentation today, is to state that observability is expensive, and I truly believe into this. But I would like to discuss the question why it is expensive. Let's try to find out together why and what we can do with that. So back then, when everything was better, like the grass was green and air was fresh, everything was just simpler. As an engineer, you could have developed your application. You knew every bit of it. You know how to run it. Does it feel healthy? Like you can check just logs, tail it logs to see if it's healthy. Maybe it's emitting 1 or 2 metrics that are very simple to understand. And you knew exactly what's happening to your app. But then something changed. Like we all know that technical IT industry right now is driven by big tech companies. Companies that have thousands, hundreds of thousands of engineers doing their job every day. They also switch in between companies. They're making public speaking, they're making articles. So they spread in this culture from the big tech companies on the industry. But we need to keep in mind that tech giants, those big tech companies, they were built in the era of cheap money. Investors' money were mostly concerned by the scale, by the speed of growth rather than efficiency. Because of this, those tech giants were more tend to promote complexity instead of efficiency. They had to know they had to build systems that can scale infinitely because that's what investors want. And this culture, from my perspective, just encourage waste of resources. So let's see what experience is right now. So now we run much more complex systems. We probably run systems that we do not fully understand. And the systems are that complex that it's even hard to put together all this, combine together all these building blocks to make the system to run. So the industry recommends us, hey, you can have a blueprint, a chart, which will do everything for you. And what you need to do is just type Helm install. So engineers type Helm install, it deploys something, it runs somehow, but I doubt that all the engineers understand what it's actually doing. So why observability is expensive? Well, I think it's because systems we run become more complex. The more complexity is in the systems, the harder is to describe what they actually doing inside. It's harder to understand if they're healthy. So we need more telemetry to express this complexity. More telemetry means that you expose more logs, more metrics, and then monitoring systems that collect this telemetry also need to be more complex because they process in much more data now. As engineers, we build systems from the ready blocks, like from open source solutions or some other solutions. They are already done, and industry encourages us to not reinvent the wheel, but use the ready blocks out there on the internet. Just use them. But the thing is that those blocks, they have many users. And they were designed for many different use cases, and they're probably not tailored to your specific use case, which means you get more complexity than you actually need, right? And because these systems are these building blocks doing more than you need, they also emit more telemetry than you need, just in case, because, maybe you will need that tomorrow, maybe no, but anyway, it is there. Complexity is there, and it is already described with these telemetry signals. But remember this, every emitted metric sample contributes to your monthly costs. And it also contributes to your cognitive load, because the more complex system is, the more telemetry it exposes, the harder it is to understand how it is working, especially in the middle of the night when something breaks. How observability vendors trying to deal with that? Well, they're likely not focused on the root cause. They're more focused on the symptoms. They're following this path of increasing complexity and increased volume of the telemetry. So they promote themselves as, hey, we can collect more signals, we can process more data, we have more efficient database engines to deal with more data, we have better compression to store more data. And again, we have infinite scalability, of course, for infinite cost. And sometimes it's even worse. Some observability vendor says that exactly how much money you need to spend on the observability, like 20-30% of your infrastructure need to be dedicated to observability. Of course, it's not as negative. They're like mostly capping the price you need to pay so you don't pay more. But anyway, it's surprising that there is like a threshold. Okay. Are there any positive future changes, any upcoming trends that could simplify this experience? And the answer is, as for every question right now, is to, hey, use AI. Well, maybe AI can make writing your queries easier, right? Maybe AI can read all those metrics that are exposed and answer questions instead of you. Maybe AI can understand how it works. Well, I don't believe in that. If as engineer we run a systems that we do not completely understand, and then we use AI that we do not completely understand to help us with that, I think it just creates more complexity, more uncertainty. It makes it less deterministic. So I don't really believe in this trend. What is the average observability experience right now? For this demo, for this talk, I spun up just a clear, fresh, new Kubernetes cluster on Google Cloud. This is what I have when I run kubectl get pods. I have a lot of systems running on. I didn't run any positive workload yet so far. So it's just the bare Kubernetes cluster. It has many systems inside running, and I don't really know if I understand everything that is happening inside. So what my natural next step is, I'll Google like how to monitor Kubernetes. And you will find like Prometheus KStack or VictoriaMetrics KStack or something like that, a Helm chart that will help you to monitor that. Here I will try to use VictoriaMetrics KStack because it promises this chart is all-in-one solution to start monitoring Kubernetes cluster. So I trust this description and I hope it will solve my problem. So I type Helm install and I got a bunch of new services. Well, as VictoriaMetrics developer, I understand what they're doing, but as an average engineer who is not as familiar with ecosystem, it's just a bunch of new services that are running on your hardware, consuming resources, interconnected. Somehow more complexity was brought in to deal with another complexity. So I'm as an engineer, I just hope it works. Okay. So the thing is, there is no such thing as a free lunch, which means that every service that you run, every telemetry, every metric sample emitted by that service, it contributes to your monthly cost. It increases your expenses. And this is why every observability vendor, like a cloud observability vendor, have the pricing calculator. If you go to AWS Managed Prometheus or Google Cloud Managed Prometheus, they have this calculator and you will pay for every additional sample that you add into that calculator. And it will contribute to your monthly cost, right? So this is, in the end, it's just the amount of money that you pay. And it will be very sad to pay those money for something that you don't actually use, right? So how to understand what you use or not, or what is useful metric or no? There are not so many use case scenarios for metrics. So most important scenario is use it for alerting rules. Alerting rules are the most critical part of the observability. They can ping you even in the middle of the night if something is wrong. Observability without alerting is not observability. So that's very important. Then you have recording rules, something that like makes alerts and dashboards easier because they pre-aggregate the data. Then you have these dashboards like Grafana dashboards for global system overview, or for monthly reports, or for something like a global overview of your system with all the interconnections. And then you have ad hoc queries, queries that you occasionally run during incidents, or maybe during some investigating or making a report or something like that, something that is not used every day. So from this, we can deduce that useful metric at least need to be queried by something or by someone. Like someone needs to read it, because if no one reads about that metric, maybe no one even know it exists, but you still have to store it and still have to spend resources on it. How to find the metrics that you don't use so you can get rid of them? Well, with rules and dashboards, it's doable. Like they have them expressions, metric selectors baked in the rules expression, in dashboard queries. You can scan them, and probably you can build a whitelist of metric names that you are using, right? So with the whitelist, you can drop everything that you don't use. This is what, for example, Mimir tool can help you with. It can analyze your rules and dashboards. But how to deal with ad hoc queries? With ad hoc queries, it's much more complicated because no one knows exactly every query that is being executed in monitoring stack. And maybe even if you do this, if you capture every query during like last 30 days or something, it requires a lot of analysis to understand. And again, it will result into just a whitelist of metric names that you need to keep and drop everything else. In VictoriaMetrics, out of the box, you got the Cardinality Explorer view. This view is very helpful in order to understand what exactly is what you store. So this screenshot was taken from this Kubernetes cluster that I talked before. I installed this kube stack, VictoriaMetrics kube stack on it to monitor it. And only for this, to monitor the cluster and monitor VictoriaMetrics itself, it requires me storing like 63,000 of unique time series. Okay, and that's a lot. I think I don't believe that I know every metric here, right? So let's see what I actually store in my time series database. I see here top 10 most expensive metrics here. And for example, I see that API server request duration, a seconds bucket metric, accounts for 8,000 of unique time series. So my most expensive metric so far in this database. It accounts for 12% of all the load. If I drop it, I get my 12% back of my resources. So it's important to go for top 10 metrics first when making such decisions. Another part of this table view is columns request count and last request. They are very important because they show when last time this metric name was queried and how many times, right? So for example, I can see that my most expensive metric, API server request duration, never ever was queried. So if I drop it today, like right now, I'm just getting back my 12% back and no user experience will be hurt. It is not part of alerting rules or dashboards. I checked all my dashboards and it didn't contribute to this. So it is safe to drop it. I have another metric, API server request SLI duration, which is actually in constant use. I see it was used many, many times, and last request was a few seconds ago. It is very likely that this rule is part of some alerting or recording rule because it like constantly evaluates. Okay, another thing is flag. Another metric is flag. I see that it's not constantly evaluated, but it was queried a day ago. So probably it's a part of some ad hoc query or a dashboard. I can't say for sure if I can drop it. Probably no, probably not yet. I need to monitor it for a longer time to see if it was queried again. Okay, a short demo time to show you how it works. So here I have my VictoriaMetrics UI that goes out of the box. I have this page explore cardinality, and here I'm checking just the metrics that I have in my Kubernetes cluster that I told before. I see all my top 10 metrics. And for example, this is my API server request duration, the most expensive metrics that I told. And I queried it actually 2 days ago when preparing to this talk. So I see that it was queried 2 days ago. I see that another metric of my API server response size buckets was never ever queried. I can go inside and I can check what labels it consists of. I can see that the most expensive label here is resource because it accounts for 100 of unique values. And that's probably what contributes to its cardinality. So I can take this metric, for example, and I can probably drop it, right? Because it was never ever queried. But how can I be sure that it was, how this counter works? So if I go to query and I actually execute some expression with it, like this, and I get back to my previous tab and refresh it, I will see that it was actually queried a few seconds ago. So this is how you can be sure that this metric name tracker is actually working. Every time someone runs a query from alerting rule, from the dashboard, or from ad hoc queries, this sync will account for this request. And it will give you this view on whether this metric used or no. Okay, let's get back to slides. How we can use Cardinality Explorer to make decisions. So first you check if this metric is in top 10, because if it's not in top 10, it's probably not worth bothering, right? If you, in this previous case, if I drop the metric which accounts for 12% of my whole workload, it will be super beneficial. I do it once, I'm freeing up 12 resources in one action. That's super cool. But freeing up metrics, deleting metrics that are like consuming less than 1%, maybe not so beneficial. So if its metric is not top 10, like do nothing. If its metric is in top 10, we check in its request count. If request count is more than 0, and we see that these stats are collected for like more than 30 days, then probably we don't need to do anything. Probably we need to wait for more time because this metric usage stats just were freshly resetted and might not account for the whole picture. You need to know at least like, I don't know, for 30 days or for 60 days of stats. Okay, if stats are older than 30 days, and this metric was never queried during the 30 days, probably you don't need it. So just easily drop it. Okay, but if this metric was queried occasionally, and this but occasionally was not more than 30 days before, probably you still need to wait it, observe how this metric will be used in the future, but so far it's not needed to drop it. But if it was queried like more than 30 days ago, this one time it was queried more than 30 days ago, consider to drop it. Maybe it was just queried by mistake or by just checking what this metric does and was not never ever queried before. However, you're never sure. You need to understand what this metric does and make decision on that. Okay. So VictoriaMetrics Cardinality Explorer comes out of the box. You don't need to enable it. It helps you to see what exactly you store, how expensive this metrics is, and it allows you to find those metrics that were never queried, that are occasionally queried, and that are repeatedly, constantly queried every second. By the way, this metric name usage is exposed as API, so you can use it programmatically. Not needed to go to the UI to check it all the time. You can use it using some automation. Okay, alerting, the most critical part of the monitoring. What could go wrong with that? So here on the screen, I have a typical alerting rule called kube control manager is down. It will notify me if kube control go down. It's super simple in expression, but this alert will never fire. I would ask you why, but this is an online conference, so you won't able to answer. So I'll give some options on the screen. So it will never fire because control manager will never go down, which is a false assumption. Everything goes down at some point. It will never fire because we don't scrape metrics for this controller manager. Well, to verify this, I need to go to my collector settings to see all the targets, to see if I have it or no. Or maybe I can just run this query up job kube control manager in my as ad hoc query to see if I have this metrics. But the thing is, I won't be able to distinguish if I don't have this metric or I have just a typo or just wrong job name. So you see this metric, this alert here will never fire because someone made a typo. They used one letter L when they had to use two. This is why it will never fire. In VictoriaMetrics, you have the alerting page, which is also enabled by default and available for everyone. So you can just go to this alerting page and you can see all the groups that have the specific label called no match. No match shows you the amount of rules within the group that match no time series. You can click on it and you can see which specific rules don't have it and investigate what's happening. Let's see on demo. So I have this alerting page here. I have all my rules. I have the ones that have no match. And I can investigate why they don't have match. I can run these expressions and see what is happening to them. And I want to show you another good thing important thing about this stuff. So I have the alerting rule called service down. It looks like that. It's supposed to notify me about when some of these job names will go down. Let's see how it works. This expression is pretty simple, but I want to simplify it even more. So here I'm checking my up metric for job VM single, if it equal to 0, and everything is fine, right? Everything is fine. This alert is not firing right now because it doesn't satisfy expression. I can verify if this alerting rule is working by removing this comparison with 0. And it works, right? I see that I have this metric. I have this metric here, so alerting rule is working okay, everything is fine. But you know that the very important thing about this is if I make a typo here, if I put the job name that doesn't exist, I will have the notice from VictoriaMetrics saying that, hey, no match. This query doesn't select any time series before applying this comparison. Maybe you have a typo, or maybe this metric doesn't even make it to the database. It is not there. And this is very important to understand specifically this use case, because you can run some rules that have no match. And probably you even check if those metrics exist in your database, you run that rule, but someone then renamed the job or renamed the metric name. Like Kubernetes constantly changing their metric name, so deprecating something, and that changed while you had this rule. So how would you know that that rule stopped working? And this is exactly where VictoriaMetrics alerting page can help you. We have a very good blog post about never firing alerts and typical mistakes with that on our blog. I encourage everyone to check it for more details. But in short, this alerting page can help you to find those rules that do not pay their rent, right? Because there are two important things. Alerting rules that never work, they give you this false feeling that everything is okay, but in fact, they do not catch the bad cases. That's very unpleasant situation. And the second thing, alerting rules or recording rules that don't match any time series, they just using your resources, but they give you no actual benefit from it. So it's okay to either fix them or get rid of them. And you can also use this programmatically. So you can just run some alerting rules that will notify you if alerting expression matches no samples or recording rules produces no results. And this helps you to understand whether you run those useless rules that are just using resources for nothing. And while doing this preparation for the slides, I actually convinced myself again that monitoring is too complex. So I was checking this alerting page and I found a group called Kube Scheduler Rules, which comes out of the box with KubeStack. And it has the rule which produces no data and it has no match. So this rule is based on the metric called scheduler duration seconds bucket or something. I checked, I don't have it in the database. I do not collect it. So what it is, I decided to Google it, what it is. And I found that this metric was actually deprecated 2 years ago. Okay, but why do I still have it? Where do I get it from? Turns out that VictoriaMetrics Kate stack fetches this metric from the Prometheus Kate stack. Okay, let's go to the Prometheus Kate stack. Where do they get it from? And they get it from another repo called Kubernetes Mixins, where these rules are programmatically generated again. And we see that this file was actually updated 6 years ago. And this is like a separate repo to Kubernetes maintained by limited amount of people. Of course, I believe they did their best, but my point with all these dependencies and all these metrics that observability is very complex. There are many systems involved there. These systems are changing, and just trusting something that you downloaded from the GitHub and thinking that it covers all the bad use cases and that is all correct is a false assumption. You need to check what actually you run and how it is working. Of course, I filed a pull request with the change to this repo, so hopefully this metric name will be updated. Okay, so how VictoriaMetrics help you to deal with extra data? It has all these features built in open source version. Everyone can use it. It is enabled by default. You can see what metrics you store, how expensive they are. You can find metrics that never ever queried, so you can safely drop them. You can find metrics that occasionally queried. You can find those that are repeatedly queried. Maybe those repeatedly queried metrics can be optimized, pre-aggregated somehow to also free up some resources. It allows you to find alerting and recording tools that make no sense and just give you this false feeling of safety. And yes, all this is open source on the Apache 2 license, and I encourage everyone to use it and try to understand your monitoring better. And that's it. Thank you for listening.